Good morning. This is Sandy Roberts, starting out week 2 of classes here at Sneed. I try to get ahead of assignments with videos, just because that makes sense to me. Chapter 2 is the need for security, and a lot of these things you're going to relate to in this need for security. When you look at this table, how many of those things have happened to you personally, or malware, or phishing? Don't you get phishing all the time? I could show you my email box right now, and this morning I had several phishing emails. I had several spam emails. Um, if you, the attack, uh, most of us probably have not had our computer taken over by a botnet that it wants to rule your computer. The insiders, one of the things I just said in a video, with it sometimes it's people. Denial of service used to happen a long time ago, and I it's been revised. No, let's see. Do you see that 40%? See, it's went down. I remember when Yahoo got so many uh, emails sent to it that it just had to shut down the server. So denial of service, unauthorized use or access, and you'll see in this book as we go that um, there's a huge balance between making sure that everybody has good user IDs and passwords, and maybe it's biometric that you use the retina of the eyes, or the thumbprint, the thumb or the hand or the foot or something to let somebody have access. Um, but that there's a balance there between letting them do it. Password sniffing. When you see the rules in this book, is your password set up that way? And I've been thinking all weekend since I've been looking at this chapter that I'm going to change some passwords. I have no control over the passwords that places like Sneed State gives me. So, but anyway, passwords and what they look like, are they written down that someone that wanted to get into your system could? Those kinds of things, outsiders, web browsers happens, um, financial fraud, website defacement. I teach beginning and advanced web starting in the spring, wireless networks and what happens, unauthorized use, instant messaging, theft of IP addresses and what can happen. Uh, you see the explorative social networking sites all the time. So all of those kinds of things and what can happen. Now let's go back. I really like this book. The more I've read it, I like the way it's presented and laid out. I like the way he gives us lots of resources if we want it in visuals. A bad neighbor makes us early stirs, which is both helpful and good husbandry. So what that means is a thief can teach you things, a hacker can teach us things. One of the things that I have done is ordered one of the hacker's books. He did a tell-all book, and that's going to be my next read. You learn a lot from those people. So in this chapter, the organizational business need for information success, security, why that successful security system is a shared responsibility between the higher ups in IT, understand the threats and the common attacks, the relationship between those threats and what we have to do to protect ourselves. The mission of information systems to ensure that assets, the information and the systems that they run on are safe, useful, up to date, current, all of those kinds of things. If no threat, then the improvement of that system. The threat of attacks is a constant and ongoing and evolving thing. I didn't realize, and I'm sure most of you probably didn't, is that security systems were in place as soon as the first networks were put up there. So you would see that when computers first started, viruses started. It's just a fact of life. So protecting the organization's ability to function, the data that it collects and uses. And that data can be lots of different data. Like here at Sneed, when I log into my Sneed, I have 3 different windows. I can do a student window so that I can see your information to advise you correctly. I have an employee link, because I am an employee. What's the other one? But anyway, the information of a company, its data. It may be a company that produces something, so its data is a list of inventory items or a list of raw material suppliers, a list of clients, all of those kinds of things. This safe operation of applications running. And you know as well as I know that Microsoft has not always been diligent in protecting its software. I hope I have shown that to so many classes. I'm not sure I have in this one. Every application, and if I have, just forgive me, every application has its own unique port that is, let me just call them software ports, and you will learn this in your Intro to Networking class. If I've done it, please forgive me. TCP and UDP software reports. So that when an email comes into your system, the computer knows where to route it so it can be open. Now there's roughly about 65,000 of these, and they starting at the very first one, and each one of them is dedicated to a particular service of the computer or a particular application of the computer. So Microsoft wasn't really good at securing all these ports when it wrote operating systems, so that's why it got so many viruses and all that kind of stuff. So you see that if you take a look, and you'll want to take a look at this more closely when you can, you'll see that it goes all the way down to here, and the other couple of thousand or 1,500, whatever it ends up to being, it says that they're dynamic or private and cannot be registered with IANA. IANA is the organization, and that's on our PowerPoint page 50 in your book. And I skip around on the slides because it just makes sense to me. There are geographical locations that are of IANA that are responsible for keeping track or maintaining the databases of all the IP addresses in the world. And you can see that they're divided up. There used to be 7, and now there's 8. No, there's still just 7. I just was looking at this one as the 8th one. There's 7 locations of those IANAs and the number of IP addresses that they have put out, and you can see the usage trying to keep up with all of those lots. So we are global, and they just keep getting bigger and bigger. Now, just to keep on with the PowerPoint, you want to be able to discuss the need, why a security program should be in place and share the threats, the relationship between the threats and the attacks, ensure that the assets are protected, whether they be data or physical hardware, how to improve your company and know that it keeps on going. A security system, the main functions is that you want to protect that organization so that it can keep on working day in and day out, protect the information and the data of that company, the safe operations of applications, and that's what got me right to showing you that list of ports, the technology assets. Facilitate the security program management, computers of interest, terms of business impact and the cost. Without data, an organization loses its records of transactions and ability. We know that, right? All of us are data driven, and that's why databases are so very important. Databases really do keep track of all of our money and all of our bills and everything virtually that we do. Databases keeps our Facebook pages going. Databases keeps our email going and all that kind of stuff. One of the hardest things is to keep that data going while it's in transit. And I just showed you how object-oriented programming code is written. So Word documents, for example, have some of that code in the background, so viruses just can attach itself. We don't teach that anymore, but I'm going to press Alt F11 and bring up the code window. We can write code against the Office suite, Word and Excel, so that viruses can attach itself right there, and there's code that's already there that describes this Word file object. This is the properties window, what I was showing you a few minutes ago, that all objects have properties and methods. So that's the way it works. That's the way a lot of virus code gets attached to documents as they're floating around the internet. So we need procedures and environments in place that allow us to protect the data and the organization, ultimately the organization. One of the things that we'll see, I believe it's in Chapter 5, is the different types of firewalls. And I always knew personally that there was hardware firewalls, but there was also software firewalls. So I learned a lot in that chapter to see that there are, in fact, 5 different types of firewalls available to us. So security services grow as the organization grows. As they're outdated, their new ones are put into place, all of that kinds of things. Now, threats, and this is where it gets a little bit fun for all of us, I think, is to look at the kinds of threats, and we see them every day. A potential risk to one of those assets. Now, remember that the assets can be data, but it can be people, it can be hardware, and it can be software. All of those parts of an information system that we learned in Chapter 1. So not only management needs to be informed, but everybody that works there needs to be informed. And they have to be. All employees in an organization have to follow the rules. This is the way we're going to do email and this, all those kinds of things. It cites a survey that said that 67% of one organization had malware infections. 11% had hackers in, and that's really not uncommon. One operating system that Microsoft put out, and I can't actually remember which one it was now, it's been several years ago, there was somebody ran around their code for months before Microsoft ever knew that somebody was in there running around on their code. So anything online has the potential for hackers or malware kinds of infections. When I first started teaching computers, there were some of them that actually were pretty fun. You don't see those anymore. There was a virus came out that Mickey Mouse just ran across your desktop, things like that. Now they're done for really bad things. Okay, we looked at that just a few minutes ago, the types of threats and the attacks. This is not a really complete list. It just gives you a breakdown of how that's maybe changed in some areas, how it used to be a lot more than it is now. Okay, now the threats. Intellectual property, privacy, where you're stealing software, copyright infringements. SNEED has now on its syllabus your right to the things that you create while you're in class. Before the internet, let me just put it that way. If you wanted to copyright something, you had to pay generally a lawyer, fill out a form to send this to the copyright office of the government, then they would copyright it and send you a thing back that you owned it and all that stuff. Well, now that the internet has happened, you don't have to really do that. Anytime you publish anything, whether it be a web page, a picture, a poem, or anything like that you publish online, it is yours. Actually, intellectual property belongs to you at the time of creation. What happens sometimes is you've got to prove it was yours. If somebody steals it from you, can you prove that you created that thing? So intellectual property is the act of creating it, but it's also the act of you have to secure it. Teaching web development about 10 years ago, we talk about copyrights right from the beginning because it's so important in web development. And I say to my students, actually at that time I had an assignment, and I said, do not, please, every class I teach, I said, please do not do anything illegal in my class. Well, the students had a project to work on all semester to create their own website, and we published it. At that time, GeoCities was a site that was free. It was easy to use, so I would create a class site and then do links for all of the students. 2 months after that class was over, a dean at our college got a letter that someone in my class had blatantly copied his copyright site and put it up there on our class and threatened to sue our college, as a matter of fact. I had no way of knowing that was a copyrighted, that he had copyrighted that site. It was a phishing site. I had no way of knowing it. So, the dean sent that student a letter and changed his B to an F, and we took down the site. Nowadays, after that, I would take down those sites immediately and then try to pay more close attention that, in fact, the students had to create those sites in class and couldn't just put one up that they'd copied from somebody else. Anyway, deviations in quality of service, ISP, local area networks, wide area networks problems, trespassing and espionage, forces of nature. So attacks is not just people, floods. You have heard my story maybe already. I do use that story so much. When the 10th anniversary of 9/11 happened, they did articles of survivors. And I read an article of this guy who said him and his boss had started down the stairs and were, in fact, almost at the bottom, out of the towers. And his boss realized that he did not have his computer backed up, his databases backed up. So he went back to get it. And he never made it back down. So that, to me, shows you how important backups are. But it also shows you that forces of nature, and that wasn't really nature. It was a brutal attack by terrorists, but still, those buildings burned. Human error or failure, whether it's an accident or just a plain, we're all human, we make mistakes, and that's true. Extortion, blackmail, and that's what we see happening with Ashley Madison right now, right? They stalled all that data from that cheating site, and now the 19 kids and counting guy was the first one to come out and say, okay, I did it. Somebody blackmailed him right at the very beginning. He was one of the most known names on there, and they got him right at the beginning. Sabotage or vandalism, a lot of times that happens by just employees that are disgruntled. They get mad at the company, and that happens a whole lot. Attacks, learn the differences between viruses, worms, macros. What I just showed you is called a macro in Word, Excel, but Word and Excel are not the only applications where you can add macros, code to do a particular thing. Failures, just plain failures. It happens. Our data, our software runs on machines. And what we do, if it's big important servers, is we do uninterrupted power supplies in case power goes out. We have, like Google, for example, the last book I read on Google, at that time they had 6,000 servers in the Silicon Valley there in California. They had 6,000 redundant servers in the desert there somewhere. And, California is going to have a major earthquake, so they had it in the desert. And then I believe they put some redundant servers up in the Northeast, like Boston or somewhere like that. So software failures, hardware failures is a very important part of securing the information system. Bugs, code problems. I have on my machine, every time I shut down this video software that I'm running, it tells me that it has a function error every time. People write code, and as such, it's subject to have problems. Unknown loopholes, and that's what I was talking about. Microsoft's operating system, they didn't close up all those software ports when they wrote some of the earlier operating systems, and that's why they got so many viruses written against Microsoft systems, is they just didn't protect them. Antiquated or outdated technologies, hardware and software lies, and then plain old theft. There we are. The compromises to intellectual property, the creation, the ownership, and that's what I was talking about earlier. The most common IP breaches involve software piracy, and that's what happens. What you learn in networking, and intro to networking class, is that there is a header section of all transmissions that go across lines, whether those be physical line or a satellite or whatever they are. One of the things that goes with it is the IP address of that particular machine. So those IP addresses is what it's talking about being changed in transit. The two places, Software and Information Industry Association and the Business Software Alliance, I am going to, when I get through with this video, find the URLs to those, and I'll put them up, and then I'll re-put up the PowerPoint so you'll have them and won't have to find them if you want to look at that. Enforcement of copyright laws. And honestly, it's just like somebody stealing your identity. You can't prevent it, and it sure can cost you a whole lot of money if it happens to you. So sometimes there's not technical security that can be put in place against people and fraud and all of that kind of stuff. So we need to be diligent in the things that we do. All of the different support systems for the information system, the internet service, communications, power, all of those things. There's lots of things that can cause hardware, software, paper failures. Internet ISPs, and we all have to pay an ISP to provide our internet service. What happens with wireless is that the organization, whether it be Sneed or Books A Million or wherever you pull up McDonald's and type into their wireless, is they have a pool of IP addresses, and you just get the next available one. So the ISP gives you your IP address for your home machine. Your phone walking around has it, and it just goes from satellite to satellite wherever you are. Outsourced web hosting, and that's what I was just talking about. A lot of websites do not set up their own servers and their own security. They just buy existing usage on a company. Like I just said a few minutes ago, GeoCities used to be one of my favorites, but it has since went out of business. If I can just get back to the browser. I'm going to put free, okay? Because that's what I use in the web class. And you'll see that there are lots of free web hosting sites, and they're responsible then for your IP address and for your security while your website is on that site. But you saw that. Now, I don't know the case of Ashley Madison. That just makes a real good site to talk about because it's in the news. I don't know if they hosted their own or if they had their own IT people inside. So do you see what I mean? They were hacked. Is your bank secure? Is all the sites that you do business with online, are they secure? So that's one of the things that you have to decide, and you want to make sure that your ISP keeps your computer and stuff safe. Now, your ISP does have a firewall, but now you're responsible for your own virus protection, all that kind of stuff, obviously. Communications, other services, we all know that loss of these, cause an individual company to fail. Cost of online service provider downtime, just in the case of Blackboard. Now, we use it, and some students like to use it at midnight to 5 o'clock in the morning, something. Most systems like Blackboard, your virus protection, they do upgrades in the early hours of the morning. That's because that's when the least users are. So if you're in the habit of doing all of your work at 3 o'clock in the morning, then when Sneed sends you a notice that the Blackboard's going to have downtime, that's what you've got to pay attention to. Blackboard actually has about a 98 something uptime on its system. So that's what this is talking about, and how much it would actually cost a company to have downtime. Obviously it would cost Amazon or eBay a lot more money than it would cost another company, just with downtime. And whether that downtime comes, whatever the threat is that causes that downtime, it's still downtime. Now, some of you may be really new to computers. At home, you want a surge protector. You know what those are. And it's not just so that you can plug more than one thing in. A surge protector actually protects against power irregularities. It's like lightning, of course, can come in and zap things on that, the power. But if you have a surge protector, it will protect against those fluctuations. For example, when your power does go off, when it comes back on, it's a big surge, and that big surge can blow out a motherboard on a computer. So you use power supplies just for other reasons than just lightning. So if you don't have a power supply connected to where you charge your laptop, you're vulnerable. It's just a fact of life. Get your power supply for the fluctuations, and then for when, it can't help when the power goes off. It can't provide you power, but it can protect it. Espionage, unauthorized individuals, competitive intelligence, whether that's competitive from the outside or competitive from the inside. Yeah, it happens. The book talks about soldier surfing, and I just saw that this morning in class. There was a student sitting in front of another student that was obviously doing something, but it was distracting to that student. I went to Arab and became their director just for a little while down there. And we had a student that was looking at porn. Okay. So when we discovered it, I first talked to that student very nicely. I said, you cannot look at porn. How we actually discovered it was another student sitting on the row behind him and was trying to pay attention in class, but what that student was doing on his machine. So I finally had, after about warning him a couple of times, I finally had to show him that not only was it other students telling on him, but it was that I could prove it with the browser 100%. So be careful what you're doing on your computer, especially in our labs. the trespassers, if they're in the organization cyberspace, I love it. Hackers, skill, fraud, bypass controls. We know that's what we're doing. There's a picture of the soldiers of it. An expert hacker. Hackers, virus writers, it's code. For those of you that believe that you should not have to take a programming language if you're a cybersecurity major or a Cisco networking major, it's code. And the only way you really understand how someone could cripple your network with code is to take a programming language. And we don't teach it. We don't teach uh, creating unsafe scripts or anything like that, but we teach you what code can do so that you understand what it can do. So it's code, whether it's a full-blown program or if it's just a real short script that does what it does, it's still computer code. And it can be written in the very, what do I want to say, innocent languages like C++ and Visual Basic. Java, all of those languages can create unsafe scripts and code. Now this, I think I did in the last video, talked about hackers and crackers. When I first started teaching, they were all hackers. Now, those hackers, the good hackers, want to differentiate themselves between people who do it for bad, and they call them crackers. So, right here, if this author, he should have put the word cracker here instead of hacker, but they all lump into, whether they know what they're doing or not, hackers. That's what they are. And if you look online, yes, you can find websites that are designed to show you how to do this, right? Why do they hack? Some of them hack just because they want to. They want to see if they challenge themselves. Can I learn that? It is bragging rights, actually. If you don't think those anonymous hackers brag to each other, do you know how a lot of criminals are actually caught bragging? It's a fact. They brag. I just heard a conversation on the radio the other day where this group of hackers would not have been caught had they not been sitting in the bar drinking and laughing about what they had done. I am a whacker. Cracker. Okay, page 61. Hacking hackers, right? There's a website. Why do they hack? There's a website. There's a lot out there, but I like this one. 5 notorious hackers to ever get caught. The dangerous ones. Who is anonymous? This is my slide. Can you tell? It's a slide that I put in. Who is anonymous? Why do they hack? Ashley Madison's site there. I don't, if you're going to visit, okay, now, not all of Anonymous are good guys, just because some of them try to do good stuff, like Robin Hood. Not all of them are good, but Anonymous is still doing some good things. There was a terrorist what did they do to that newspaper? They didn't like what the newspaper were putting out, so they attacked them. Well, Anonymous started attacking those terrorists. So take a look at Anonymous and what they do and who they are and all of that kind of stuff. Espionage and trust. There's the cracker. Cracks or remove software protection to prevent unauthorized duplication. But honestly, crackers are just used nowadays to say that they're the unexperienced ones, or they're the ones that are unskilled and just learning. I don't know, whatever term you're using. Hackers and crackers. Tweakers hacks the public telephone system to make free calls. And that's really true. I had a friend that the phone company called him like at Monday morning and said, have you been using the internet all weekend nonstop? It's like $3,000. And he said, of course not. I haven't even been on it. I've been hunting. So somebody had hijacked his telephone number and used it all weekend to run their website. You know, password attracts, where do they try to crack it and all that kind of stuff. One of the things that this chapter tries to show us is how to do good passwords, and that's just one of the things that are a pain for us. How many passwords do you have? I don't know. I probably have at least 25 or 30. And no, they don't all need to be the same password. They could get into all of your stuff at one time. So if you write them down and somebody finds that list, you're in trouble. You see what I mean? There's a lot to do with passwords. Now take a look. The password length is really more important than the makeup of that password. And what most sites are going to tell you is that the password should have a letter. Passwords. Letters, both low and uppercase. They should have numbers, and there's only 10 of those now, right? And they should include symbols, right? So that's what I do. I might have a password, and this is not one of my passwords. Something else. You know, that's the kind of passwords I create. But now that I have read this, what I have started to create is that mix of upper and lowercase numbers, letters, and symbols, and longer passwords. Do you see, the longer the password is, the harder it is for them to crack. Now, you know that we have a lot of processing and a lot of RAM and all that stuff, so they'll eventually get it cracked if they want to, but you can see that a password in this, if they didn't have any software that helped them crack passwords, it would be futile. Right? It would be futile. So if you don't learn a whole lot from this chapter, be sure to learn how to change your passwords. Do not use your name. Right, do not use your initials. Do not use the company that you work with. Do not use Sneed. You know what I'm saying? All right, sorry. Forces of nature. We're good, right? Well, forces of nature. Human error or failure. And I just did this example in my programming class this morning. And it's a true story. There was a company, I read this article, and I always read news, and I always read Tech Republic's, one of my favorite sites. There was a company that sued a former employee. They already had fired him, but they sued him because they didn't document their programs well enough for the next guy to come in and read the code and the documentation and alter it and change it and improve it and keep it up to date. They didn't win because it was their job to make sure that employee done their job while they were working there. But this says that employees are the greatest threat to an organization's data, whether they mean to or not. One of the things that we are told not to do is to take our roles into a lab or a classroom and leave that role laying there so that students can see other students' S numbers. You'll see one of the things that I do in class is I try not to directly link to, with the overhead projector going, the grade book. You know, things like that. Sometimes I'm in a hurry, so it can be inexperience, not the company not training them, or just assuming something. So when you go to work for a company, my rule, of course, dealing with people is to be professional at all times. I have had students make me mad, but very few times have they actually seen that I was mad. I never retaliate. I never do that. I try to remain professional. If I lock my office, I do leave my rolls laying here because I have a locked office and I have a locked building. But, securing your data, all of those kinds of things. Tommy Two Story, wannabe hacker, all thumbs doing things, confuse the copier with the shredder. Oh, let me just use Hillary Clinton again, please. I'm not trying to be political. Hillary Clinton used a server that was unprotected doing government classified business. I don't blame it all on Hillary Clinton. She should have had a better boss than that. I'm sorry. Get off that horse. Human error. Classified data, and we all know that a guy stole a whole bunch of data and then flew to Russia. He's still there, right? But he fully believes that that classified data should have, we should all know about it, right? So what does our government tell us, and what do they don't tell us? Uh, errors in data. And that's one of the things that I harp on so much in database classes, is if the data is wrong, it's bad, right? So there can be errors in data. It can be deleted. It can be changed. It can, store it in unprotected errors. I promise you, during registration, it is somebody's job at this college to back up the registration system, the classes that you are taking, and take a copy of that to another physical location. After 911, I saw all of these data centers being built, in Birmingham especially. And they were built, have you ever noticed a bank being built with these massive amounts of concrete and steel inside that concrete and the blocks and all that? Well, when Google builds this data center in Stevenson, Alabama, they're going to build that building so that it can withstand most acts of nature, that it can withstand most people just getting into it. So anyway, after 9/11, I seen companies building these buildings so that they were a data storage center. So a company could back up their database and bring it to them for an alternate location in case the building burns down, or, the building is surrounded by people or whatever. We know that one of the things that happens is that people use social skills to try to get our information, right? So don't reply to that email that you don't know where it came from. I, on my phone, do not call anybody that I don't know their number. If it's a legitimate business, they will leave me a voicemail and tell me to call them back, right? I don't answer phones that I don't know where they're coming from. People are the weakest link. You can have the best firewalls, all of these other things in place. That's the guy right there. He's got a book out. He was one guy that spent time in jail because he hacked. That's, um, uh, we have to be really careful. We have to be diligent. We have to have firewalls. We have to have pop-up blockers. And if you take web development, I'll show you how very easy it is to create a pop-up. Can I show you something? I drive you crazy, don't I? But I hope it's interesting to you and adds something to the class. AL.com. This is one site I go to every morning to keep up with what's going on in the state of Alabama. But if I click anywhere inside this window, it just takes a little bit of time to load. If I click anywhere inside this window, a pop-up window comes up. It made a liar out of me today. I guess, I've already been here. Maybe it's a first thing, or maybe my browser's going, but it'll do a pop-up window, an ad selling me something. So, anyway, that's how it's very easy to create. It works on an event though, that pop-up window. So we have to have spam protectors and, all of those kinds of things in place. um, we want to make sure that we're aware of those social things. There was a guy on Facebook that just tried to make me a friend. I didn't know him. Uh, Somehow the friendship was accepted without me actually clicking it. And the next thing I knew, he sent me a message, and the next thing I didn't read it. The next thing I knew, Facebook was banning him from my account. Social engineering. People trying to get at you being a nice guy, those kinds of things. Phishing, the websites or the emails look legitimate when they really are not. There is something called third-party cookies. I'm going to do just an internet thing, a browser thing, so that we make sure that our third-party cookies are turned off, that you understand what cookies are, and all of those kinds of things. So we need one dedicated just to the internet and the browser, and I'll do that. Won't promise today, but I will do it. Showing you what it looks like for somebody to use social engineering to try to make it like they're a good guy and they just want to help you, that kind of thing. A cyber extortion, that's what's happening with Addison Madison, and we know that credit card theft is regular. What those people had to do with what those sites do, even if you don't have to pay for it, you've still got to give them a credit card number, right? Even though, so those credit card numbers were stolen. Once you've had your credit card stolen, whether it is a physical card or the number, you actually going to have to get rid of that credit card as soon as you can. I read an article or listened to an article the other day that said, if identity theft happens to you, it costs you lots of money to secure and get that person. Whether or not they ever come to trial or not, it still costs you a lot of money. It costs you a lot of time just to get credit cards, squared away. Sabotage, threats, whether it's organized or not, web defacing, hacktivist or cyber activist. Let me just show you another thing. And this is VeriSign. And I'm sure you know them, whether you know them or not. And this company actually bought them out. This company has the market for, if you are buying something online and you scroll down, this company has the market. They're like an insurance. If you do business online, you do need that company or a company like it that is going to, if you're hacked or whatever happens to you, they're an insurance. So VeriSign has been a company that's just been around for a long, long time. That other company bought them out. So see, it's been reset and they should have sent it off. This company bought them out, but they still have the market in providing the certificate, that it is a good site and it's safe to do business on that site. So the threats are rising. Of course, we knew that. We know that warfare is, cyber terrorism, all of that stuff is growing. Cyber activists wanted, right? Software attacks, malware, viruses, all of those things. Whatever it was designed to do. Software, malware, viruses can do lots of different things. Some viruses are actually not even harmful. here I go again. I'm going to drive you absolutely crazy. And we have to put known viruses because some of them are going to be created today that we don't know about. Some of them are created today that your virus protection doesn't know about them. How many are there? How many known viruses are there? Bunch, right? And how much damage they did, right? If you want that to be yours. Let's see. It gives you the system that it was geared to, right? To go to. So, that's a comparison. That's not the list of how many there are. And if you use Norton or McAfee or Avast or any of the other free ones, can I just put computer viruses to distinguish it from human viruses? How many are there? How many are there? I don't know today. Okay. So there's a bunch, right? There's a bunch of them. If you do a system backup, and I'm not teaching hardware support this semester or software support for that matter. If you create a system backup on your machine, and where I store that file is on a external hard drive. You can store it on a flash drive. You don't need to store it on the machine. But if you do a complete backup of your system, right, today, and when that generates a file, and I save that file off to my external hard drive, it puts a date on it, so I've got that backup of my system, and I create a lot of files, and I have a lot of pictures and a lot of music that I don't want to lose. If I get a virus tomorrow, I can restore my system, and it honestly does. If there's nothing showing on your machine, it installs itself on that machine. If I get a virus tomorrow, then I can restore my system as it was before it got that virus. So that's one of the things that you learn in hardware and software support is how to do that. And you want to make sure, if you don't want to lose everything that's on your computer, that you do a backup. So protects it against all of those things that can happen to your machine. Malware, virus, worms, Trojan horses. Those things are a little bit different in how they actually work. The virus is code segments that attaches itself to an existing program or an existing file, and it takes over some kind of control. A worm just duplicates itself till it fills up your hard drive. A Trojan horse, and I've got one on a machine at home, and I honestly need to capture that so you can see it. It's called, can't think of what it's called. My virus protection let me get it because it didn't know it when it came out. A Trojan horse is a piece of software that looks like it's legitimate that really isn't. And so when I got that, I was going to upgrade anyway. I just left it there because I knew I was never going to get on the internet again with that machine. I can't think of what it's called. Okay, this is the most dangerous malware attacks to date. Okay, My Doom. That one, I didn't see as much, but look how much damage it caused. I Love You. That's a little guy I talk about all the time. It affected 10% of the internet at the time. The little guy said, I didn't know it would do what it did. He wrote it so that it called out any generic file name, .jpeg, all of those files, those image files, he told it to delete them. That virus, when he released it, went straight to England and wiped out a lot of museum artifacts, the pictures of those things that so caused a lot of damage. He did not serve any time. He was from a company, Malaysia or Singapore, I don't remember, that did not have a law against writing viruses at the time. So big. Code Red, the SQL Slammer. SQL is a programming language that you use with databases. Melissa, all of these now. Cornflicker, Microsoft still has a $250,000 reward out for that guy, and he's kept his mouth shut. You know, he hasn't told on himself. I'm going to look and see. Oh, shoot, sorry. This is 54 minutes, and we still have a lot. I'm going to do a part 1 and a part 2, stopping right here. Have a good rest of the day.